Okay, so we ready? Yep. These are called reciprocal trigonometric functions. Can anybody remember what reciprocal means?
Diagonal times that equals 1,
So, whatever a number times a reciprocal equals 1. So if it's a reciprocal trigonometric function, and I have cosine, let's say, what would I multiply that to get a 1?
Sine.
1 over cosine, thank you. And if I have a sine, what would I multiply that? Okay. And obviously, tangent, right? Now, these reciprocals have a name. They have a specific name. 1 over cosine will be called secant. Abbreviation? Please, if you see this, don't call it sec. No, it's secant. Okay? Just like this isn't cos or cos. It's cosine. This is not a sin, sine. Okay? Same thing here. This one, 1 over sine, is going to be cosecant. This is not okay? That's what it said. This would be cotangent. Abbreviation, afraid to say, cot. Okay? So we've got secant, cosecant, cotangent. Is it clear what these are? Yes? So, let's remember these. Sorry, this is 45 and this would be?
45.
1 is 30.
And this one, if this is 30, this is 1, this is 2, and this is 3. Okay? So, obviously, if cosine of, let's say 45, what's the cosine of 45? Adjacent over hypotenuse, right? 1 over square root of 2. Then secant of 45 would be square root of 2 over 1. Right? Okay. So, is this understood? Because she doesn't want it long, so I'm making it really short. So, let's do a problem. May I erase this?
No.
No, okay, no.
Yes.
Let's do the secant of 330. May I write here?
Yes.
Secant of 330 plus the cotangent of 480. So this would be where? This would be here, and this would be 30, right? And this would be 480, 360, 120. It would be here, 30, 60 here, okay? So that's cool, because if this is 30, this is 1, and this is square root of 3, and this is 1, and square root of 3, right? And square root of, and this is 2. Does everybody agree? Mm-hmm. So the secant of 330, secant, the way I remember it is, if this doesn't have a co, then it's got to be over a co. So secant is with cosine, and cosecant has to be with sine. Does that make sense? You can't have a co with a co. Cosecant can't be 1 over cosine because it already has a co. So cosecant goes with sine, and secant goes with cosine. Okay? Yeah. So this is the secant of 30 degrees. This would be secant is cosine, 1 over cosine. Cosine is adjacent over hypotenuse. This is the inverse, so it's hypotenuse over, so it would be square root of 3 over 2. And is it positive or negative? It's positive, right? And this one would be, tangent is opposite over adjacent. So cotangent is adjacent over opposite, right?
Why?
because it is a reciprocal. Remember what reciprocal is? It's the flip one. So you flip it, and you've got, what is it? What is it? It's opposite over adjacent, adjacent over opposite. Adjacent is 1 minus 1, right? Over 2.
No,
And whole
that's
tangent.
By?
Tangent.
So it's square root of 3.
So it's 2 over square root of 3. Positive. Yes?
No.
No?
No, it's tangent. It's opposite over adjacent.
It's opposite over adjacent.
So
Which
then it would be
1 over square root of
adjacent.
3.
it's opposite square root of 3.
No,
Over
it's
adjacent.
not. It's 1
it's-
over square root of 3 and
Cotangent is 1 over square root of 3.
Because so it's opposite. A tangent is opposite over adjacent, so it's adjacent over opposite.
Right, okay, so adjacent over opposite. So it's 1 over square root of 3.
Yes.
And it's a minus 1.
Yes.
Okay, thank you. So we have, and you can do this, right? You can simplify. Yes.
I don't know. What do you do if you have secant U30? I don't know what you do.
Okay, let's go back here. This part's understood.
Yeah, the reciprocal.
Why do we do this? Because we can. Okay, so we just, but because they're trigonometric functions, we're gonna give them a name. And their name is this. We're gonna go a step further and I'm gonna tell you. Cosine is adjacent over hypotenuse. Therefore, its reciprocal is going to be hypotenuse over adjacent. Does that help?
Mm-hmm.
Then this one's gonna be hypotenuse over opposite. And this one is going to be adjacent over opposite. Okay.
Okay.
You get it now?
I got it. It's just the opposite.
No. Yes, it is just the opposite. Okay. So that is the first part. And then we go to permutation notation. May I erase?
Yes.
Yes.
Not the
Not the example. Not the example. This is understood?
Kind of.
Who said kind of?
I know. He's asking me if I remember.
That's because I think you said it before.
What?
That's permutation.
Probably.
But
He's asking me if I remember.
Oh, so you were answering him, not me. Okay. Okay, so now got lipstick for the video on and everything. Permutation notation. What does that mean? Have we seen this before?
No.
It's new. Okay. Permutations, you remember what they are? Mm-mm. Permutations are combinations in a specific order, or with specific restrictions, okay? So if they tell you, for example, how many permutations are there of 22 things, 22 things taken 6 at a time. How would you do that the way you've been doing it so far?
Draw 6 boxes.
You 6 boxes because it's 6 at a time, so that means you've got 6 positions, right? 22 things.
22.
You start with 22
21.
because repetition's not allowed, I suppose.
Doesn't say.
Doesn't say. Well, we assume that they don't allow repetition. So 21, 20, 19, 18, 17. Okay? Now, if we look at this, we can do it using factorials. How would you do that? This is the same thing as, do you know what a factorial is? You remember factorials? These guys,
Yes.
right? So let's say that this is kind of like a factorial, but without the end, right? It's the 22 times times 21, times 20, 19, 18, 17, 16, all the way down to 1. So in the top, we could say that we have 22 factorial. Would you agree? But it's not complete. Why? Because we are missing, what are we missing? From 16 on, right? And so it turns out that we have 22 minus 16. Would you agree?
Mm-hmm.
No. We need a 16 factorial down here.
Why?
Ah, good question. Why? Because we've got 22, 21, 20, 19, 18, 17, 16 factorial. Would you agree? And if I have 16 factorial in the bottom,
You can cross it out.
and I have this left,
But why did you choose 16 on the bottom?
because from 16
You
on,
don't have it.
I don't have it. And this looks like something familiar. This looks like a 22 factorial to me. Does it look like a 22 factorial to you? So how do we get this 16? Well, we have to relate the things that we have. And it turns out that 22 minus 6, guess what it gives me? 16. So we've got 22 factorial, 22 minus 6 factorial. Would you agree?
Mm-hmm.
So from this, we can draw up a formula in general, which would be, this would look like this. The permutations of 22 things taken 6 at a time, okay? So we can make a formula. It would be n factorial over
22 minus 6.
n minus, what do we call it, r? What do they call it? R. Factorial. And this now becomes n and r. N being total number of things. R being number of things taken at a time. Can you do it? Does it make sense?
Mm-hmm.
Do you want to know? So, by the way, this can also be expressed, you'll see it in other books like this. P and R, INRP, just NR. There's a bunch of other ways, but these are things that you'll see, okay? Know that it's the same thing that you learned if you see it in another book. So, find, now that you know this, find this. Easy.
16? 12? 12
factorial.
factorial? 12 minus 4 factorial.